Hello students, we went over 5.4 earlier, or rational functions, graphing rational functions, and we did 5 steps basically. 1, vertical asymptotes. 2, find the horizontal and slant asymptotes. 3, find the x-intercepts / the zeros. 4, find the y-intercepts, in other words plug in 0 for f, and then 5, find additional points. So use your notes. I'm kind of doing some of the questions that we did on our notes that we didn't get to in class. Starting with the front, we actually did something like this, but I thought it wouldn't hurt to do another one with you, and then I'll get to the ones that we didn't cover in class, which is slant asymptotes and holes in graphs. So step 1, find the vertical asymptotes. Part of step 1 is to go ahead and factor when you can. So the top actually factors to x plus 3, x minus 1. And the bottom actually factors to x minus 2, x plus 1. And from here, I can tell the vertical asymptotes what makes the denominator equal to 0 is x equals 2 and x equals -1. These are my vertical asymptotes. Okay, so step 1 is done. We're going to move on to step 2. Step 2 is find the horizontal asymptotes. So like I said in class, there's 3 rules. If you have n is less than the degree of the bottom function is less than the degree of the top function, then so rule 1 was if the degree of the top function is less than the degree of the bottom function, then the horizontal asymptotes y equals 0. Rule 2 is if they matched, or if the degree on the top equals to the degree on the bottom, then you're going to take the coefficients, which this one's 1 and that one's 1, of the lead term. So meaning this is rule 2, and so we're going to get 1 divided by 1, okay, or case 2, which is going to be y equals 1. And this is y equals 1 is the horizontal asymptote. Okay, so step 2 is done, and we're going to go ahead and move on to step 3, which step 3 is find the x-intercept. To find the x-intercept, you set the original function equal to 0. But what I told you in class is the only thing that really matters is setting the numerator equal to 0. And I'm going to go ahead and use the factored form of the numerator, because if the numerator is 0, that means the whole thing is 0, right? If the numerator is 0, that means the whole thing is 0. So that tells me that the two solutions here is x equals -3 and x equals 1. So these two are my x-intercepts, and I can go ahead and write the coordinates that there are. It's -3, 0 because they're intercepts, and 1, 0. That's an x-intercept. Step 4 is to go ahead and find the y-intercepts, which you're just going to plug in 0 for x. So I want f of 0, which is actually easier found just doing it in your head. That's 0, 2 times 0 is 0, minus 3, that's -3. 0 minus 0 over -2, that's -2, so that's 3 over 2. Okay, and then step 5, that's you want to find additional points. So for this, I would just go ahead and use a calculator to find the additional point. So like I mentioned in class, at this point, step 5, I would go ahead and start graphing what you have from steps 1 through 4. And then we'll see if we actually need additional points, and if we need additional points, then we'll go ahead and find them using the calculator. So here I have vertical asymptote at x equals 2. I have another vertical asymptote at x equals -1. I also have a horizontal asymptote at y equals 1. I also have x-intercepts at -3, 0, 2, 3. I have another one at 1, 0. I have a y-intercept at 0, 3/2, which is really 1.5. So 0, 1.5 is right here. Now from here, I could tell I'm going to need additional points. So I'm going to use the calculator to generate some additional points. Some good ones to find out would be x, maybe -2 would be a good one to find out. Also, maybe possibly 1.5 would be a good point to find, and maybe even 3. So a few points before the vertical asymptotes, maybe a point or so after the asymptotes, or in between the two asymptotes, and then a point after the asymptotes. So we're going to go ahead and find those. Okay, so using the calculator, I got negative 0.75. I also got negative 1.8 and 3. I can go ahead and graph those points. So negative 2, negative 7.5, 1, 2, 3, 4, 5, 6, 7. Then 0.5 would be somewhere around here. 1.5, negative 1.8, 1.5, negative 1.8 would be about here. So that kind of tells me how that graph's going to look, or that part's going to look on the graph. And then 3, 3. So I can kind of tell from these points that the graph's going to be guided by this function, and it's going to go to the asymptote there, and also that this graph is going to be guided by the asymptote here, go through these points, and be guided by the asymptote there. Now this is enough to kind of tell me, okay, it's going to be guided here and go through this asymptote and this direction, and so now I have the graph of this function. Of course, you can kind of verify these graphs by using your calculator. Go ahead and calculate it on a TI-84 or 83 calculator, graph it, see if it matches, and you should see that it does. Okay, so we're going to move on to the next one. Okay, so this is problem F on the front page. So we're going to go ahead and start with this one. We're going to follow the steps again, and we're going to find the vertical asymptotes. And so we want to look for what makes the denominator equal to 0. That's step 1. So you'll easily see that x equals negative 1 is what makes the denominator 0, and that is your vertical asymptote. Step 2, we're going to use the three rules that we talked about in class. Whether the degree of the top is less than the degree on the bottom, the degrees on the top and bottom matched, or the degree on the top was 1 more than the degree of the bottom. This would be case 3, where you have the degree on the top is greater than the degree on the bottom by 1. So in this case, this is what we didn't cover in class, which was you want to use polynomial long division and divide these. Okay, so to do this, you're just going to divide the lead term. So you're going to divide x by negative x, or you're going to divide negative x squared by x. So that's going to give you negative x. Multiply negative x times x, negative x squared. Subtract, you get 0. There's nothing here. So that means you're done. This is what we call an oblique asymptote. The result, or the quotient, after you do polynomial long division, only if the degree on the top exceeds the degree of the bottom by 1. Okay, which in this case it did. So this is the oblique asymptote, not necessarily a slant asymptote, but an oblique asymptote, which not necessarily a horizontal asymptote, but an oblique asymptote. This, another name for oblique would be slant asymptote. Okay, so step 2, we found the oblique asymptote, so that we're done with that. Step 3, what we want to do is find the x-intercepts, which we're going to set y equal to 0. So we're going to set the function equal to 0. But like we said earlier, the only thing that matters is if you set the top, or the numerator, equal to 0 and solve. So you can easily see, if you divide by negative and you take the square root, the only thing x can be is 0. Okay, so this is the x-intercept 0, 0. Anytime you see 0, 0, that kind of leads us to the next step. You kind of know f of 0 for the y-intercept. If this is the x-intercept, f of 0 is going to be 0. You'll see it if you plug it in, right? 0 squared over 0 plus 1 is 0 over 1, which is 0. So that also tells you that that's the y-intercept as well. Okay. So we found step 4. We're at the point where we need to find additional points. But, like I say, I would graph everything you have and then see if you need additional points to begin with. So I'm just going to do a couple of hashes here. And then we're going to go ahead and graph. So starting from the top, we have vertical asymptote at x equals negative 1. We'll draw a vertical asymptote here. We have a oblique or slant asymptote at y equals negative x. So that means y-intercept is 0. I'm going to graph this, and that has a slope of negative 1. So I'm going to go down 1, right 1, down 1, right 1. And there is my oblique asymptote, and my graph should be guided by those two oblique by these two asymptotes. Okay, so from here I know that I have an x-intercept at 0, 0, which also happens to be the y-intercept. So I'm going to go ahead and put a point there. Now, at this point I realize I don't have enough to determine a shape. So we will continue and find additional points. So some good additional points to find would be maybe some points before the vertical asymptote, like -2, and a point after the vertical asymptote, like maybe 1 and 2. Okay, so we're going to go ahead and plug those into the calculator, and then it'll give us some values. Okay, so after I plug in -2 on the calculator, I see that I get 4, and then if I plug in 1.5, I see that I get -0.9, and then if I plug in 3, I get -9/4, which as a decimal, -9/4 is -2.25, which would be better to graph as a decimal. So I'm going to go ahead and graph these. -2 is here, 4 is 1, 2, 3, 4 up here. So that right there kind of tells me it's guided by those two asymptotes. 1, -0.9 would be about right here. 2, -2.25. 2, -2.25 would be about here, which, let me check that real quick. Okay, so I realize I have a correction to make. So I'm going to have to do back up here. So I should have did -x times x is -x², and then -x times 1, that's going to be -x. And then from there you would change the signs of these. So that would be plus, that would be plus, and then you'd continue the process. You'd divide by x, and you'd end up with 1. Okay, so that changes it slightly because my asymptote would actually be at 1 or -x plus 1. So there's the y-intercept, and then you go down 1/1, down 1/1. So there's my that would be my asymptote right here. Okay, now which makes more sense with the points that I had, because now I have -2, 4, that one stayed the same, 1, -0.9 would be about right here. Okay, and then maybe let me do this in let me do the points that I have in red. Okay, so -2, 4, 1, -0.9, 2, -2.25 would be about right here. So I can kind of see how this is going to go. This is guided by this slant asymptote here, and by the vertical here. This one's guided by this asymptote, the vertical asymptote here, and the slant asymptote in this direction. Okay, so that's my graph. You could also graph it into your graphing calculator and check that that is the case. But yes, make sure you make that correction for the slant asymptote. Okay, so we'll go ahead and work on the next problem. Okay, so we're going to go ahead and work on h of x, which you'll find on the back of the first page of your notes on 4.4. And so we're going to do the steps. So the vertical asymptotes, you're going to see what makes the denominator 0. So that's step 1. So what makes the denominator 0, you'll see that it's x equals -2. So step 1 is done. Step 2, we're going to find the horizontal asymptotes, and we got to determine which case is this. Is this case 1, case 2, case 3 that we talked about in class? And we'll see that this is actually case 3, because the degree on the top is 2 and the degree on the bottom is 1, which is 1 greater than. So case 3 is kind of like what we did on the last question. So we're going to divide 2x² plus 3x minus 5 using polynomial long division. So we're going to go ahead and carry this out. So how do we do this? We're going to divide the lead term by the lead term. So 2x² divided by x is actually 2x. 2x times x is 2x². 2x times 2 is 4x. And then you would go ahead and change the signs of these. So that would be minus, and this will cancel. This will be -x. Bring down the -5, and simply you're going to divide by the lead term here, by x. So then -x divided by x will give you -1. -1 times x, -x, -1 times 2 is -2. Change the sign, that becomes plus, that becomes plus. That cancels, that'll be -3. But this doesn't really matter anymore because this is my slant asymptote. Okay, so my slant asymptote is y equals 2x minus 1, or also known as oblique asymptote. So we'll graph that in a little bit. Okay, so step 3 would be find the zeros. So we're going to set the top of the function, or top of the equation, or the numerator of the equation, equal to 0. Usually I would have factored by now, but we can factor this on top. So I know this is 2x times x, right? And so I got to get a combination that multiplies to 5 for the outside. So probably if this is, it may not be factorable, but give me a second. And okay, so this will be the final example. We have more on there, but like I told you, we wouldn't get to all of them. So I'm just going to go ahead and take out the carry on the step. This one's an example for when you would see holes in a graph. Okay, so we're going to do the same steps. We'll do the vertical asymptotes, and like I said earlier, you probably want to factor if you can. So this one happens to factor to x minus 2 times x plus 1. So that tells me that the zeros of the denominator are going to be x equals 2 and x equals negative 1. And that also tells me that those are my vertical asymptotes. Okay. So now that I know those are my vertical asymptotes, I'm going to move on to the horizontals. And in class, we talked about 3 cases. Well, the degree on the top is 1, and the degree on the bottom is 2. So the degree on the top is less than the bottom. Therefore, that tells me that the horizontal asymptote is y equals 0 automatically. Okay. Moving on to step 3, we're going to set the function equal to 0 for the x-intercepts. So really, I'm only concerned with the numerator. So solve that. We'll quickly get x equals 2. So we have the x-intercept 2, 0. Okay, so this would be our x-intercept. And then step 4 would be to find the y-intercept, which now we plug 0 in for x. So we want f of 0. F of 0 is just 0 minus 2, that's negative 2. 0 squared minus 0, that's 0. Minus 2 is negative 2, so that's 1. So now I have the coordinate 0, 1 as my y-intercept. Okay. And then from there, I usually tell you just go ahead and graph it and see if you can get it. But let's go back to the point of this here. You'll notice at this step 1, and I should have did it here, but what do you notice? That x minus 2 over x minus 2, that cancels. Whenever you get factors that cancel, that actually means that you're left with 1, and then 2, that whatever makes that factor 0, which in this case is, oh yeah, and I want to edit this actually. Whatever makes that factor 0, which is x equals 2, this is actually a hole in the graph, not a vertical asymptote. So that's the hole. The vertical asymptote is actually this one here, okay? And that's the vertical asymptote. So that's the hole, that's the vertical asymptote. And we'll see what that means in a second. And in fact, what it also means that the graph is actually going to look like this graph. Okay, so it'll actually look like 1 over x plus 1, okay? But we're going to graph it all the same as we've done all the other ones. So at this point, at step 4, we're gonna go ahead and graph the asymptote that we know. So I'm just going to put a couple of points here. Okay, and from here, I'll do the vertical asymptotes -1. I also have a horizontal asymptote at y equals 0. Okay, and from there, I also know that I have an x-intercept at 2, 0. So I'm going to do 2, 0 as a point here. And I also know that I have 0, 1 as a coordinate there. Now I probably do want additional points because I don't have anything on this side of the vertical asymptote. So maybe like -1 and -2. So I'll make a quick table for step 5. Additional points. Okay, so I'm going to do -2, -1. I'll just plug them in. -2 minus 2. Well, yeah, we'll use a calculator. Okay, so on the calculator, I get, if I plug in -2 into the function, you get -1. And then I should realize I don't want to plug in -1 because that's the asymptote. That'll be undefined. We could probably plug in -3 as well. Okay, so -3, I get -1/2. Okay, plot those points. So then I would get -2, -1 is here. -3, -1/2 is here. So that kind of tells me right there that this graph will go through those points and is guided by the horizontal and vertical asymptotes. So that kind of tells me that this is going to go this way. And this one is going to be guided by this asymptote, go through this point, but then also be guided by that asymptote right there. Now additionally, the purpose of this question, the purpose that we went over this question is to talk about the hole. Whenever you have factors that cancel this way, whatever makes that factor 0, that will be the hole. Okay, so what does that mean on the graph? So on the graph at 2, in fact, you're going to edit this, and at 2, that coordinate, we're just going to literally put a hole. Okay, and what that means is that this graph is undefined at 2. Why? Because if you plug 2 in here, you get a 0 in the denominator, but it didn't create an asymptote because the factors canceled. Okay, so this is when you have a hole. That's how you represent the hole in the graph. And if you notice, this graph is equivalent, or the graph, it looks like 1 over x plus 1, which is basically 1 over x shifted over 1 to the left. Okay, and so that's basically the idea. So we talked about graphing rational functions. We did an example like we did in class. We also talked about ones with slant asymptotes, and then we also talked about ones with holes in them. Okay, so that should give you enough to kind of complete your work for the week. I'll see y'all next week. Take care. Hi, Timmy. Hello. What are you doing?